Hello. So my name is Sourav. I'm from India and working at ANC Corporation for the last 11 years, mostly in the field of HPC, vector supercomputing, machine learning, compiler, and data science related stuff. So in all my career, I've started it with the specific supercomputer which NEC has. The name is SIMD. So I had a very sound background with the kind of different optimizations, the memory side and the CPU side, and on the hardware side also. So using that at my lab, so Mr. Isizaka and I have, first of all, we teamed up and thought of that probably we can make something with the use of compiler technology, which will be used, which can be useful for the community for the speed up. And since Python is something which is known as it's very slow, and the library based on Python is also slow. So the target area we thought of, okay, let's pick up some data science area where usually spend a lot of time and struggle with optimization. And that is where we thought of developing a library named FireDucks. So it's nothing but an accelerator for the pandas, although it's a new name, but probably people who are from the pandas background, they don't need to learn anything new. For the user, it's same as pandas, but down the line it is very different. Like all the methods and the architecture is different. So definitely I'll be introducing them and discussing them in detail in upcoming slides. So okay, to start with, why this domain, like why pandas or this kind of thing is important. So for that, probably we can understand the complete cycle, the complete model of a data, like the data analysis on daily basis. So what we usually do is like we collect data from different sources and then mix the data is in a very raw format, which is not very readily digestible for an AI and machine learning to do a lot of productive training. So that is the ideal time where we can like transformation of the raw data to the AI like acceptable form is taking a lot of time. So this is something called we call data preparation. And once the data is prepared in a structured way, it can be like ingested to AML model, AML algorithm, and then the model can be trained. And if the model is not that good, then we need to do a lot of re-engineering on the data, and this loop is continuing. So that is the way. But research says that the most of the time in this entire cycle, so around 70 to 80% time is spent on the preparation of the data. So because it's very important for the model to perform, if you don't have a good data, the model will not be that accurate. So data preparation is a very important step of the intercycle, and at the same time, it is most time taking part. So now, since it's important, so what is the library used for it? So there is a very popular library called Pandas, which is here for the last 12 to 13 years, I believe. So nowadays also, if you check in the downloads, it is on the very top and around more than 100 millions a month. So not month, basically, I believe, yeah, month. So it is having the downloads. So, but the problems, probably it is very well known to the user who are currently using Pandas. Like, so if you start with the Pandas, so Pandas, when it was developed that time, the big data was not in the picture. So it was like for the Python user who can easily, instead of learning SQL kind of thing, easily deal with some like Python methods, and they can just load the data and do a lot of cleaning and operations. So that was the ideal start of Pandas. But the core principle, it is not multi-threaded. So even if in your system you have many cores available, but it will be executed on a single core. So that is the primary reason of its slowness. So since it is single threaded, it is very slow. And since it is very slow, if you have a large data and if you want to do a lot of simulation on that data, so you need to wait for a longer time. So that is ideally the biggest pain point of a scientist. And of course, if you're using on a cloud, then waiting time also increase your cloud rental cost. At the same time, it will not be very good for the environment because it will emit a lot of CO2 during the execution. So that are the core challenges of Pandas. So of course, if you are doing some prototype and small data, it will not be that much. But when the data grows in size and your prototype becomes a production ready code, that time you'll start realizing the problems. So, and another thing, one very important thing is that in Pandas, we have different ways, like even if you want to do the same thing, but we have different ways of doing that thing. So now how you have actually implemented that, that heavily impacts the performance of your application. So the writing style of not only Pandas, I believe it's for other libraries also. So it's very important that we think on that line also during the implementation. So today's agenda will be like that. So how we can improve Pandas and how we can think efficiently whenever you start writing some particular analytical query. Yeah. So now challenges associated with the migration of pandas. So of course, since pandas is slow, so there are many libraries being developed around it, which is trying to address these challenges. But the primary problem with this library is something that because since the pandas is here for the long time, so many third-party libraries, for example, visualization library, data cleaning library. So there are many useful libraries like why data profiling is there for the profiling kind of thing. Missing number is there for the, to analysis the missing data in your missing elements in your data, right? There are visualization tool like Seaborn, Matplotlib. So they internally use the pandas data frame kind of thing. But if your library is not compatible with pandas, your like the new library is not compatible with pandas, so it's difficult to deal with those third-party libraries also. So that is the challenge that user whoever having existing application or whoever is trying to use different library which is using pandas, they are facing a lot of challenges during this migration. So there are library, for example, to talk about the first one, which is called the Modin. So it is fairly compatible with Pandas. So they said that one line, just change the import statement and you can execute your Pandas code as it is. But it's not that fast. Ideally, it's not for the single node system. So it's for the multi-node performance, but still it's not that faster. So you can definitely expect some speed up from Pandas, but it will not giving you the optimized speed up when using modding. There are the alternatives like Task and Vex. So they are quite faster in comparison to modern, but still the performance is not that level. And of course, if I talk about the compatibility with pandas, they're not enough compatible. You will find a fair compatibility, but if you have an existing code with a lot of pandas API, then it cannot be readily executable without any changes in the code. So that is again a challenge. Like first, you need to learn the API, you need to learn the data structure because you're from pandas background, you know series data frame, but you need to know their data frames as well. What is happening under the line into their data frame. So that is the ideally challenges to know the new library. And of course, something happens, for example, in pandas, there are a lot of it has a rich set of API. So if you're using some API and the library is not supporting that method, you need to perform some kind of manual, like, okay, this method is not supported by Dask, for example. So I need to perform two pandas mechanism from pandas to copy the data, from Dask to copy the data to pandas, do the stuff at pandas side, and then return back the result to that library side. So that is a primary thing. And if you have a quite large data, the migration takes time. After migration, we'll start testing whether everything happens fine. So overall, it is a cost performance thing. Like even if you're paying this migration, how much cost performance benefit you'll be getting. So that is a challenge. And for that, there is another new library, not new, I believe it is very popular in the last 3 years. So it's pop polars. So it is blazingly fast with the intuitive API. But the thing is that it's not at all compatible. It's very much incompatible with pandas. So if you are from the pandas background, so you will need to spend quite time to learn polars and its different execution models. And of course, the existing application cannot be executed, of course. So, it is change a lot of things. So that is the challenges. That is where we at NEC, there is a new library which is thought of. That is the primary motivation that we need to improve the performance issues pandas. At the same time, users should not need to have this kind of challenge. Like the migration should be very easy, such that even if there is FireDucks, they should not know anything. Like it's fine for them. Like they don't need to learn anything new. So if you know pandas, that's sufficient. So that was the primary motivation. So from which library FireDucks, the research start around 3 to 4 years ago. So internally, it has its own compiler for the query optimization part. The query optimization similarly done by the SQL engine. So basically, it's a high performance data frame library with a compiler for different level of optimization. I'll be explaining that in upcoming slides. But what is the important thing is that it's the speed and easy of use. The speed wise, it is multi-threaded. So you can take full levels of your system. So how the number of cores available, you will get that parallelization possible. At the same time, it is lazy as in terms of execution model. So instead of executing each API right after they are called, they will be accumulated in some sort of instruction. And during the execution, when the actual execution is required, that time all the instruction will be like optimized using the compiler, and the optimized instruction set will be executed by the executor side. So that is the core thing by which it can make a lot of optimization. But the important thing is that although it offers a lazy execution model, but non-lazy mode like the Pandas eager execution mode is also possible. But you don't need to change the method of the program. So just by configuring an environment variable, it's possible to switch between lazy and eager model. So that is a thing, like you don't need to spend time in learning something new. And as a part of drop-in replacement, definitely not only a existing Pandas application, definitely if you have a Pandas application, you can directly execute it with accelerate it with FireDucks without any changes, without any modification code. But also if you are using any third-party library like Seven, Scikit-learn, etc., which internally use Pandas, that can also be migrated without modifying the any code of it or whatever it is. That is, in any like Pandas based code can be seamlessly integrated with FireDucks and can be accelerated obviously. So the core features is once again like FireDucks is having a lazy execution model. The lazy instruction, the instruction which is compiled during the like develop like instruction processing phase, that will be optimized just in time during the execution. During the execution, it will be multi-threaded, so you will get quite faster data analysis. And the important thing is that since it is very fast, so it will be cloud friendly for you because you don't need to pay a lot of cloud cost if you're using on a cloud on any Pandas application. At the same time, it will be eco-friendly because it is not going to commute it attribute to that much of CO2 emission. But the most important, it's that if you know Pandas, that's sufficient. You don't need to learn any new thing. So neither you need to relearn or neither you need to unlearn anything. So that is the major thing, like any existing application can be readily executed when you want to use it with FireDucks. Now let's have a quick demo of all this thing, like how much compatibility is or what is the performance associated with it. So it's a very simple like where you can say of which is doing some kind of moving average calculation on a Bitcoin data for the last 3 years. So it does load the data using the Pandas read CSV. After loading, it's create a window and using the rolling method, it perform the mean calculation. And once the mean is populated, it's plot the result. So that is the idea of this query. So if you check the left side and right side, left side is using import pandas, so it will be executed by pandas, and the right side it is using import fireducks.pandas. So the import statement, the explicit import for fireducks is fireducks.pandas. That is the change. Probably you might like to make, but there is a way that you don't want to make this change also. So I'll be explaining that later. So anyhow, so now see, like if we execute that, so whenever we have executed it, what is the whether the result is same, and if the result is same, what is the performance difference? So when you execute it, we find that okay, the pandas took around 4.06 seconds, whereas the same execution, the same result can be obtained from FireDucks without any code modification or anything. So within 275 milliseconds. So you can see this, even if this simple scenario, you can achieve 15 times performance benefit. So definitely. So that is the agenda. Like if you know pandas, you don't need to learn anything new. And in order to start with FireDucks, you don't even need to listen to this talk. Just install it from the pip and just you can try it out. Accelerate any code. That is the thing. So now, what are the imports way? So one of the imports is what I just said. Instead of import pandas, you can just make a change, import fireducks.pandas. That is a simple change that you need to make. Rest of the code will remain same. So that is okay. But you may say that, for example, if I have a program and my program is importing pandas, but at the same time, I have several modules in my program, for example, module ABC, and all these modules also internally using pandas. So when I want to accelerate FireDucks, should I need to replace all the import pandas using import FireDucks pandas? So yes, for that, there is an option. So if you want to make it a complete zero code modification, you can provide an -m option along with the fireducks.pandas. So that will act as an import hook. So wherever it will find import pandas related in the entire program, so that will be replaced with FireDucks Panda. So you don't need to make any single changes in your code. When you execute a script using a Python command, just specify -m option, that is sufficient. And whenever you're using on a Jupyter notebook or Google Colab, whatever notebook platform you might be, so for that, just on top of any import, add this extension, load extension FireDucks.pandas. Enabling that extension will help you to like this kind of thing, like replacing all pandas using FireDucks pandas. So that is very simple integration in the notebook situation also. So in this way, you can see like either this your choice whether you want to see the performance of pandas and FireDucks separately, then probably you will use import pandas, do stuff, performance measurement, import FireDucks pandas, do stuff, perform measure and compare. So this way you can use explicit import. But if you're just interested into acceleration, existing code, use it with -m option. It will be accelerated without any code modification. Well, so now to start with, it's internal. So like what is basically FireDucks? It's on top for the user point of view, it's nothing new. It's the pandas only. So you will see that you are working on a pandas environment. So the input is pandas, the output is pandas, and the execution order, not execution order, the parameter order of a method, everything is same. So your program doesn't need any themes for that. But internally, what happens is that all data frame application comes with their own methods. So they have some library methods along with the instruction to generate for each of this method using a runtime compiler. So this compiler will do a lot of magic at the very first level. And once the compiler will optimize the code which is written by you, the optimized code will be executed by the kernel side. The kernel is actually the executor that will be executing the compiler optimized code, and it is multi-threaded. So number of code available in your system that can be used fully to make a parallelization possible for you. And it is tuned in all other ways, like they have tuned different algorithms. So all the algorithms related to data frame is written by us, so there is nothing which is reused. So you can expect the performance at the algorithm level itself. It use shared memory, so we avoided a lot of data copy among the methods. So this way you can expect a lot of performance. Yeah. Now what is the offering of these two layers? Like what is the offering from the compiler, what is the offering from the executor? If we talk about that, so compiler can do a lot of stuff in the code level. For example, you may write a piece of code, but that code might not be efficient. It can be expert programmer can, for example, rewrite the code to make a better way. So that is the job of the compiler. It will input your code considering that there is a lot of data frame methods, and it will act as an expert programmer to rewrite your code such that it can be executed in a better way in terms of execution ordering, the scope of the input data and something. So all this kind of compiler optimization is possible. So commonly there is common sub-expression elimination, date code elimination that is possible. There is domain-specific optimization, a lot of things which SQL optimizer does for you. The same thing will be possible for this compiler. And since it is supporting pandas, there is a different way of tuning a pandas method itself. So that is again will be taken care by this compiler. And the backend side, it's multi-threaded once again. So you can use the multi-threaded problem, which is you can just avoid the multi-thread problem that is in pandas. And the most importantly, all the data structures mostly are backed by Apache Arrow. So you will have a very sound data structures with optimized memory layout, and the memory management will very much taken care during the implementation. So you will not observe that that much of memory is consumed by FireDucks during the execution. And of course, the kernels, all the kernels program like joining, sorting, update, scratch, so you can experience speed up. So that is a fair introduction of FireDucks. Now let's jump into the different kind of hands-on of different sort of queries. First, let's understand if I am an expert programmer. For example, there is a difference. Data scientist or data analyst, the statistician, they know a lot about statistics and data science related stuff, and less into the programming. So often it finds like they have many questions to solve in mind, so they write quick programming, quick prototyping. So sometimes they are not up to the mark because of the performance. So that is where FireDucks can help you. So write any code, FireDucks will optimize it. That is the actual like you can say our code or our way of saying like saying that okay, FireDucks is there for to help. Even if you don't know how to write an efficient code, FireDucks can help you. Just leave it to FireDucks, this kind of thing. So now let's see, like even if you want to know like how to write efficient code, so what is the way, what is the label from where to start? So to start with that, so some common mistakes if you check on some 10 Kaggle notebooks, you'll very commonly find this kind of mistake. So let's start with that only, because it will be very easy for you to understand. So one thing is that same operation, the same data perform repeatedly. For example, if you talk about this simple instruction where you have a time column, which is, for example, string type column. So what you want the time column to be converted to year. You want to extract the year part and the month part of it. So ideally from the string to date time conversion, there is a method called to date time in pandas. So usually we use to date time to convert a string to date time, right? Then we extract whatever attribute we are interested for, the year, month, hour part, minute part, whatever part you can be extracting. So, but if you notice here, the time column is the input and the method is to date time. So to date time here is repeating on the same data more than one times. So to datetime parses the string data and convert the string to datetime. So itself it's costly operation, but if you do the same operation or same data for more than one times, it is going to take a lot of cost and memory also, right? So the usual way, like if you see this code carefully, we can do what? We can just compute the part one time. For example, we can compute the conversion from time string to datetime and keep it in a placeholder, for example, a variable s, and then we can reuse the variable is for the number of time we'll be using. So this is something in a compiler technology optimization we call common sub expression elimination. So the number of same common expression, just eliminate them and use it once and reuse it on the later uses. So that is something, one of the very basic thing that probably we can follow during the implementation of our own notebooks or queries. Another thing is very common. So because it's common basically when we do a lot of query analysis and then and down the line we drop some of them, but some of them still remain in our code. For example, if you see this method, it is trying to join two tables x and y on some key column. After joining, it performs sorting on the result. After that, it is performing some group by aggregation, grouping by, and calculation of max. But in entire journey, the shorted result is computed but never used within this method. So of course, if you run using pandas, so you can see that pandas will execute this method followed by sorting, followed by group, but sorting is not used. So from the computation point of view, this is a waste of computation time, right? So this kind of thing can again be detected, and you can experience this kind of date code can be eliminated during the execution when using some kind of library like FireDucks. Yeah, so that is a very core, like very basic thing that you can experience when this kind of optimization is possible, of course. So there is some article which I have written to do more about that. Definitely you can have a look here. So yeah, so inbuilt compiler in FireDucks can automatically detect all these things and do this stuff for you and optimize it during the execution, such that the finally executed code remains compact, remains all the common expression to be eliminated, all the date code to be eliminated, and it's fair optimized for the executor to perform to respect your computation time and memory. Yeah. So now, so that was one. Now let's jump into some a little complex scenario. So here I want you to have a pay a very good attention, because it's something which is very important, and it is a little complex. So it's try to say the importance of execution order. Okay, so if you are chaining a lot of methods, for example, A perform A followed by B followed by C followed by D, then what is the ideal order of performing A, B, C, D? That is very important. If we can design it our brain during the implementation, that will help. That is going to help you in a lot of way. For example, you don't, even if in a pandas you can experience 6 to 10 times speed up if you can take care of such thing for a bigger picture. Yeah, so let's see what is that. So for example, it's a sample query, and this query is trying to perform first sorting on our data on a column. After sorting, it is doing some kind of filtration on B column where all the B value greater than 1, and then it selects the E column and extracting the top two of it, because it is sorted, so top two of it will be selected. So now see, if we have a data, for example, this is a sample data having 5 columns, for example, with some rows. Now, for example, there is some color code which I use for the ease of understanding. So let's see, if I sort this, the color code will be, for example, yellow followed by red followed by green and followed by blue shades. Okay, so if this is the data and I short them, so yellow shades come first, then red shade, then green, and then blue. So that will be the sorting of the data. Then as per the query, the input data is there, I'll be sorting, and this is my sorting output. Okay, after sorting, what I need to perform some filtration. Let's see here, my filtration target is to filter only the light color parts. So only the light grayscale part, like the light colored, light shade will be filtered out. Okay, so the filtration is happening. After the filtration, I want the result to be obtained from the E column. So I will be extracting the E column, which we called as a projection, projecting the E column. After the projection of E column is done, we'll finally picking the top two of the E column, which is projected, for example, the very top two, the green and red part. So that is the execution order for this query. It probably is a very common case when you'll be writing. But here is very important thing. This is not a very ideal execution order. Even if you want to do this thing, you should consider a reordering of this instruction for the performance point of view. And why that is important, definitely I'll be doing some kind of small hands-on on it. And now first, let's understand how to think such query in an optimized way with the optimized execution order. Okay. So, and before that, I want to, although the execution order is happening, and please also pay an attention that all this data journey of data workload, we have worked on the entire data, but ultimately we are only interested in the E column part. And C and D column, which is there in the input data, that is used till this journey, but have never referenced anywhere, but they have been used in the computation. So all this temporary result is also having C and D. They allocated the memory for that, and also the execution time of sorting and doing the filtration is happening, but it is not used. So since it is not used, so it is taking time, and we should think of that part as well. Okay. So ideally, you can rethink the left hand side part query with the right hand side part. What it is trying to do, first of all, it is trying to reduce the scope of the data from the columnar level. So whatever column you are not interested in, let's first eliminate that, creating a view of your data such that you can only work on that part on which you are interested. Because in production level, you are going to have a lot of columns, a lot of rows. So it's very important to only focus on the particular part in your data that you're interested in. So in this entire journey, I'm only interested in A, B, and E column for doing sorting, filtration, and projection. So in the very beginning, I should first project only these three columns and reduce the scope of my data. And that is something we call projection push down. So as a compiler optimization technique, but it should be ideally done on the very first step. The second step is that there is a filter also associated with it. Filter reduces the number of rows from the scope of the data. So before performing the sort on the entire data, it's better to perform filter to reduce the scope of the data at row level also. So after projecting the target column, we should first filter out the rows that is not required within my query, right? So I'll be performing the filtering, the like light shaded part. So this way, I can reduce the scope of my data to that only. Instead of performing my following operation on the entire data, first reduce the scope on the columnar level, in a horizontal way, then vertically we reduce the scope of the data. After that, you can perform whatever you're interested. For example, I am interested in performing the sorting, perform the sort on the order scale, for example, yellow, red, green, blue, and after the sorting, extract the E column and take the top two of E column. That is fine. So after, from the sorting to projection, that part is something which is the demand for this algorithm. But the target input for the sorting is very important, because here for this query, because instead of using the entire data, reducing the scope of the data will reduce the lot of computation overhead from your entire journey, and that you should primarily focus on. And more than sorting, it's actually happening, for example, when you're thinking of joining two tables, because joining in an operation where the data is increases, because if you are using, if the key is not unique, then the input number of row will be increased after the joining. So that time, if you are using the unwanted columns, unwanted rows, the output of join result will be quite large, and that is going to pay you a lot of memory and computation part as well. So this way, like first of all, thinking on the projection based operation and then filter based optimization. Once that data is considered, then you can do whatever operation you're interested in. And that is a point you should specifically take a point whenever designing a particular query. Now let's have a hands-on on it. So probably it might be a little complex, but if you carefully follow my explanation, probably you will not find it very difficult to understand. Okay, so this is a snippet from a commonly very popular benchmark called TPCH benchmark. So it is ideally a benchmark for doing a lot of transaction data analysis, and it's written in SQL to do a lot of benchmark on the SQL related algorithms. So here there is a query, and the query is trying to perform something like this. And this is kind of the relationship between the input tables within this data, which might be important for you to consider, because you might be interested in to know how many columns are there, how many rows are there, or something. Okay, so let's see what it's trying to do. It's trying to perform join on three tables, as you can see from the very beginning. So not only one table is here, customer table, orders table, and line item table. That is the primary thing. So I'm interested in customer table, line item table, and order table. Okay, let me see the pointer option. So customer table, line item table, and order table. These three tables are my area of interest. Okay, you can just keep rest of the table in this ER diagram. So just focus on customer, line item, and orders. What it's trying to do is it's trying to join these three tables based on the condition where the customer key from customer table should be matched with order key, customer key of order table. So customer key and order, these two should be a match. And after that, during the joining of the line item table, what is the key? The key should be order key of line item should be matched with order key of order table. Order key of line item should be matched with order key of order. So that is the condition for joining these three tables. Okay, so since this is the code, so I can figure out, okay, I want to join these three on this condition. If I convert that particular SQL to pandas, let's try that and see how order is important. Okay, so first I'll be merging. In pandas, there is a merge method for you to do the joining. So customer is merged with the order table, and the key will be customer key and ordered key. So once this two table is joined, the join table will be joined, the resultant table will be joined with orders table, line item table. And in line item, the key is line ordered key followed by ordered key. So once this three table is joined, you have a sufficiently larger table in the picture. Okay. On that table, resultant table, what you want to do some filter operation where the market segment should be building. So I am performing the filter in the pandas way, that this is my DF at this moment. So at this merge operation, this is the DF. And from my data, I want to perform the filtration on the building. Then I should have the order date which is less than this and shipping date which is greater than this. Then I will perform again a filter where order date is less than that date and shipping date is greater than that date. Okay, filtration is done. After the filtration, there is a grouping. So I want to group based on these three key. So I'll be perform a group by. Follow after the group by, what I want to do, I want to perform some summation. So grouping, and then there is a summation table. So I will perform group by sum. And finally, I want my execution to be done in this order: order key, summation as revenue, order date, and shipping. So after the aggregation, I will be selecting the target column in the order as per the SQL query. And finally, it will be ordered by. Order by means sorting the result on the revenue for the ascending descending order, and order date on the ascending order. And top 20 should be top 20 selected on the data. So that is a simple SQL to pandas conversion for this particular query. Okay, so joining these three table, do a lot of filters on the data, then perform group by on the target columns. After the group by, perform the sorting. So that is a simple conversion. Now in this query, we just followed the SQL and convert it to pandas. By doing that, we have introduced a lot of performance issue because the table is sufficiently larger. You can see there are sufficient amount of rows associated with these tables, and the number of columns are also quite huge. So now see what we can do instead. What we can do, as I said, in the execution order is important. So for all these three tables, which is my primary objective, customer table, line item table, and order table, I should first reduce the columns which is of my interest for this particular query implementation. For example, from customer table, I only need customer key and market segment. No other columns are required. Okay. So what I should do, I should first select those two columns on the entire data. After that, what I'm interested in to see the building segment only. So I should, after the column reduction, I should do the row reduction. So that is this kind of projection followed by filter on done on the customer table. The same thing happens on the order table also. In this entire query on the order table, I'm interested on order customer key, order date, and shipping priority. So select only those four columns instead of all these columns, four columns, and then perform the filter to reduce in the row dimension also. The same thing on the line item, select all the four required columns and reduce the row dimension using the filtration on the line item, which is on the datetime shipping data. Okay, so once these three tables on these target rows and columns have been reduced, you can perform the same query. Instead of performing the merging on the entire customer table, I have performed the merge on the reduced customer table on both the row and column direction. So this way, when I do merging, I can save a lot of memory at the same time computation overhead. Followed by that, I will do whatever stuff is associated, for example, filtration, grouping by, and sorting. So just by following this execution order, that doing the filtration and projection in the very beginning of my total computation cycle, I can reduce the execution time from 6 to 8 seconds to 10 seconds. So that is the importance of doing optimization. But FireDucks will help you with this. If you're using FireDucks, such optimization, domain-specific optimization is automated. Even if you write this query, the compiler will be able to detect the execution problem and it will be optimally optimized in this way, and you can experience the same speed up. But again, this kind of thing is something we often don't take care, so we should take care of it. The last important thing is parameter tuning, which we often probably don't know, but again important when we're dealing with pandas, because it provide a lot of methods and the methods associate with their default parameters. For example, let's see this one. This try to perform a group by aggregation and sorting the result. Here I have different department. So it's first try to create a group of the department. After the department have been grouped, it perform the average of the salary of each department. So that is sufficient for the group by mean. But in pandas group by, there is a default parameter called sort, which is comes with the true. What does that mean? The meaning is that you should not only perform group by, also sort the result on the key column. The key is the department. So the result will be sorting because the default parameter is true. But ideally, you want the result to be sorted by the value column, not by the key column, which is department. So again, when sort value is here, pandas will again sort it based on the value column. So that is fairly like which is happening under the line. So probably you might not be noticing that this is happening, but it is happening. So how you can avoid such thing? By tuning the parameters. For example, since sort is some parameter which is configurable, and in this, you are very sure that I want to sort the result on the salary, not on the key column. So if you specify sort equals to false, this step which is happening, it will be eliminated by pandas and it will not be computed, and you can save the computation time for it. Now here I have only 5 rows, 5 groups. So sorting on the 5 row will not take much time. But if we have a lot of different row, for example, when I tried this method on two key A and B, where my sample data is having 100 million size, and I perform the same thing like grouping and followed by short values. One is short equal default parameter, another is short false. From 50 seconds to 30-second reduction is possible just by tuning this parameter. So this kind of this is again important, like parameter tuning kind of thing. which we probably not take care. But if we take care, we can definitely reduce a lot of execution time during a journey. Again, FireDucks is compatible with Pandas, so it can do this stuff for you instead of thinking. Instead of forcing you to think this thing, even if you write this, it can understand you, whatever your final objective is, and it can optimize based on that. Okay, to conclude, how FireDucks actually work in that sense. So basically, FireDucks has its IR builder, which we call intermediate representation, which is from the email IR compile, one of the very popular framework driven by LLVM framework. So whenever you write some piece of query in Pandas, instead of executing, it creates some specialized instruction for that. So short value instruction, projection instruction, and whenever there is a need on the result, for example, you want the result to be printed, that time the compiler actually compilation started, and it see that there is a sorting followed by projection. So that time it can think of, okay, I'm trying to do sorting on the entire data v1, but probably in my data df I have more than a and b, so there might be many columns more than a and b. So it's not good to perform sorting on the entire data. So it will first project only the A and B, which whatever is interested for this query, the target area of interest of this data. So it will project that part and do the same stuff. So once this IR is generated, you can compare this IR with this particular Python code that select the A and B with a view and then sort on this temporary and perform the sorting. So this way, actually, it can optimize a lot of your code. So our primary objective is that just write a single code, single pandas, and you can execute anywhere, because it can down the line create a new set of IR. Now this IR is compatible enough to execute on a CPU. Probably it can be translated to any GPU compatible library. So that is the way by which this IR driven way helps FireDucks to be compatible with pandas, and same code can be executed on any platform. So currently, you can definitely experience it on your CPU if you are switching using the -m option, or just change the import statement. So quickly, let's have a view on the benchmark. So I will say some benchmark. So it is called DB benchmark. So in this benchmark, we have several queries, and different library have been compared. So and you can see that of course, all this library is faster than pandas, but FireDucks is on top of it. So when you compared last month, so it was on very top of it and performed very well on this group by and joint related operations. There is another, like the TP says, I have given an example of query 3, but actually it has 22 queries, and all these 22 queries, you can see that when compared with pandas, it can fairly perform very well. There is Polar's version of this query is available also. So when you compare the performance with that, on average, Polar's was 40 times faster or for all this query than pandas, and FireDucks was about 48 times faster. So you can see that just without making any change in your existing code, you can experience speed up with FireDucks. There is another benchmark called TP6BB. So it is ideally the ETL followed by machine learning. So the same thing, just by changing the import or by changing the import hook, we can compare the performance, and you can see fairly like all the cases, FireDucks is performing very well than pandas. So well, to conclude, like how you can get to know more about it. So there is a website, you can go into here and you can see the execution model and different article on it. We have a Twitter and GitHub page where you can find the information, and definitely we have a Slack channel that is prepared for the communication. So if you like it, you may like to join here to do a lot of QA kind of thing and the communication on the support kind of thing. For the test drive, here is a Google Colab link where I have provided a notebook for you where you can have download a data, install FireDucks, and try out 3 to 4 queries and see how the simple change in the import can make it faster from pandas to FireDucks journey. So yes, with that, I am concluding my talk. So thank you for listening. So again, I would say like focus your in-depth data exploration using pandas. So don't need to learn anything new. Probably if you are using pandas and you love pandas API, and just allow FireDucks to accelerate whatever you have written using its import hook, and you will be accelerating whatever journey you have.